Welcome back to the deep dive. So we've mapped out the geography of JavaScript scope pretty well, right? Where variables live, how they nest.
Yeah, the where.
Exactly. But that's really only half the picture. Today, we're tackling the variable lifecycle itself. We're shifting from where a variable lives to, when it actually becomes usable.
Right, when does it actually come online during execution?
We're getting into the subtle mechanics, those two phases, declaration and initialization.
It's a great point. It's like knowing a house's address versus knowing when the foundation was actually poured and ready. You see a var or let halfway down a script.
And you wonder,
How can I use it before that line? It forces us to really dig into JS's specific take on lexical scope. The timing rules are, frankly, more complex than the location rules.
okay, let's start with a classic puzzle, something that really trips people up.
I think I know where you're going.
Yeah, probably. So you write this. Line 1, you just call a function, say greeting. Then, maybe 3 lines later, down on line 4, that's where you actually define it. Function greeting, console.log. Hello. It works perfectly fine. But why? Logically, the code hasn't even seen the definition yet, what it's called.
Yeah. That takes us straight back to the compiler phase. Before one line of your code actually runs, the compiler does this first pass. It finds all the identifiers, variables, functions, and registers them to their scope.
Registers them,
Yeah.
like puts them on a list for that scope.
Exactly. Conceptually, all those registered identifiers are sort of created right at the very start of their scope, the moment that scope is entered. This idea that a variable is visible from the start of its scope no matter where you actually wrote the declaration, that's hoisting.
Okay, so the name, greeting, is hoisted, registered early. But why does it already have the function itself, the actual value? Hoisting just registers the name, right? And something else must be going on.
Precisely. That's the special magic of function hoisting. When the compiler sees a formal function declaration like that, it doesn't just hoist the name. It also, right then and there, auto-initializes that name to the actual function reference.
Ah, so it gets the name and the value immediately.
Immediately, at compile time, essentially. That's why you can call that function anywhere in the scope, top to bottom.
Okay, that's powerful. But it sounds like a potential trap, too. If function declarations are fully hoisted and initialized, what about function expressions? When you assign a function to a var, like var greeting function, shouldn't that work too, since var is also hoisted?
And that, right there, is the crucial counterexample. Let's walk through it. Line 1, greeting.
Okay, the call again.
Then line 4, var greeting, function greeting, assigning the function expression.
Now, what happens on line 1?
It fails.
It fails. But how it fails is the key.
It's not a reference error, is it? I feel like I've seen this.
No. Good memory. It throws a type error. Usually something like undefined is not a function. Okay, type error. So the engine found the greeting identifier. Otherwise, it'd be a reference error. Greeting is not defined.
Exactly. The type error proves the name greeting was registered. It was hoisted. The problem was its value at that moment.
What was its value then?
Undefined.
So var hoisting is different. Variables declared with var are hoisted. The name gets registered early, but they're automatically initialized to just undefined.
Right. At the very beginning of the scope, the actual assignment where it gets the function reference, that only happens much later, during the runtime execution when that line is hit.
And you can't invoke undefined. Bam! Type error.
That's the split. Function declarations, name and value hoisted together. Var declarations, name hoisted, but value is just undefined initially. Name's up top in both, value assignment is the big difference.
This seems like a good time to talk about the whole hoisting metaphor itself. Because, you often hear it explained like the JavaScript engine literally rewrites your code.
Oh yeah, the lifting metaphor. Like it picks up all the vars and functions and physically moves them to the top before running.
Right. Super common explanation. Easy to visualize.
And helpful to a point, especially for beginners. But it's not actually what happens. It's technically misleading. The engine doesn't rearrange your code.
So that metaphor confuses the result with the process.
Exactly. The actual mechanism is that first compiler pass we talked about. It parses everything, finds the declarations, and prepares the scope by registering them.
Okay, so here's where we need maybe a slight mental adjustment. Hoisting isn't really a runtime thing, like code moving around. It's better described as what?
A compile time operation. It's the compiler generating instructions for the runtime phase. Instructions that say, okay, when this scope starts, automatically register this variable name. It shifts our thinking from runtime magic to compiler setup.
Compiler setup. I like that. It feels more grounded.
And understanding that compiler prepares the scope first really helps when you hit weird initialization bugs later.
Okay, let's switch gears a bit. Redeclaration. What happens if you maybe accidentally declare the same variable twice with var, like var student name Frank, and then later, same scope, just var student name? Does it reset?
Not a chance. With var, there's effectively no check for redeclaration. The compiler registered student name the first time it saw it. That second var student name is just ignored.
A no-op?
A no-op, no operation. The value stays Frank. And importantly, that var student name line doesn't mean assign undefined. It just means declare this if you haven't already.
Okay, var is the Wild West, anything goes. But let and const, totally different story.
Oh yeah, polar opposite. Try to redeclare anything with let or const even if the first one was a var, instant syntax error.
Syntax error. So it doesn't even try to run. The compiler just stops you.
Stops you dead. Identifier student name has already been declared. Flat out disallowed.
Which is interesting because var proved it's technically possible to allow redeclarations. So why did the language committee, TC39, make let and const so strict?
Well, the source material frames this largely as a social engineering move.
Social engineering, meaning guiding programmer behavior.
Pretty much. Allowing redeclarations, like with var, often leads to sloppy code. You accidentally reuse a variable name, overwrite something important, introduce bugs. By making it a hard error, they basically enforce cleaner, safer coding habits.
That's fascinating. A language design choice driven by preventing common mistakes, not just pure technical limits.
Right. Although, for const, there is also a strong technical reason behind the no redeclaration rule.
Ah, okay. So restriction might be more stylistic, but const has a deeper reason.
Exactly. Const has two core rules baked in. Rule 1, you must initialize it when you declare it. Const X alone. Syntax error.
Got to give it a value right away.
Rule 2, once you give it that value, you cannot reassign it. Trying to do x equals 10 later throws a type error during execution.
Okay, mandatory initial assignment, no reassignment ever. How does that make redeclaration impossible?
Think about it. If you tried to write const student name Frank and then later const student name Susan, that second line is attempting two things: redeclaration and reassignment.
Ah, and the reassignment part is already forbidden for const.
Bingo. Any attempt to redeclare a const inherently involves trying to assign a value, either the same one or a new one, which violates its fundamental cannot be reassigned nature. It's technically impossible.
So the technical impossibility for const probably made it easier to justify applying the same strictness, maybe more for style reasons, to let as well?
Seems likely, yeah. Consistency and pushing for better practices across the board.
Okay, let's apply this to loops, because loops introduce repetition. If I use let or const inside a while loop, it seems fine. Why doesn't that count as redeclaration on each iteration?
Good question. It comes down to let and const being block scoped. The critical thing to grasp is that each iteration of a loop creates its own brand new scope instance.
Ah, so the let variable inside the loop body is declared once per iteration within that iteration's fresh scope.
Exactly. New scope, new declaration instance, no conflict.
But the classic for loop trips up const. If you write for const I equals 0, I3, I++, it runs once, and then, boom, type error. Why? It's not redeclaring, is it?
It's not a redeclaration error, you're right. The problem is the I++ stuff, that increment step in the loop's header.
Is an assignment.
It's a conceptual reassignment.
Yeah.
It's trying to change the value of I after its initial I0 assignment, and const says absolutely not. Type error.
Makes sense. Constants can't be changed. But wait, what about for.in or for.of loops? You often see const key or const value in those, and they work fine.
Right. Because those loops behave differently. The variable declared in their header, const key in for.add, const value in for.of, is treated more like it's declared inside the loop body for each iteration. A fresh constant is effectively created and assigned the next key or value for each pass without needing that explicit reassignment step like I++O.
Subtle, but crucial difference in how the loop mechanics interact with const. Okay, final big concept here. This one ties a lot together. The Temporal Dead Zone, or TDZ.
Ah, yes, the TDZ.
We've established that let and const do hoist, right? The names are registered at the top of their scope by the compiler.
Correct. Hoisting happens.
So, why then, if I try to access a let or const variable before its actual line of declaration in the code, do I get that reference error? The one that says cannot access variable name before initialization.
That specific error message is your direct window into the temporal dead zone, TDZ.
Okay, break that down. Temporal Dead Zone.
Think of it like this. Scope starts. The compiler has hoisted the let or const name, the permit is posted, the spot is reserved.
Right, the name exists in the scope.
But the variable itself isn't actually ready or initialized until the JavaScript engine reaches the line where you wrote let student name or const age and 30. That period of time, from the very start of the scope entering until that declaration line is executed, that is the TDZ.
So the variable exists, it's hoisted, but it's
Right.
in this unusable state.
Uninitialized and unusable. It's in the dead zone. Accessing it triggers that specific reference error.
And we can actually prove that let and const are hoisted, even with the TDZ, using shadowing, right?
Absolutely. Classic proof. Imagine you have an outer scope, var student name, Kyle.
Okay, global or function scope student name.
Then inside, in a block scope, you intend to declare let student name Susie. But before that let line, you try console.log student name.
Okay, so if the inner let student name wasn't hoisted, that console.log should just look outwards and find Kyle, right?
It should, but what actually happens?
You get the TDZ error. Cannot access student name before initialization.
Exactly. That proves the inner let student name was hoisted to the top of its block scope. It exists there, blocking access to the outer Kyle. But because you tried to access it before its initialization line, you hit its TDZ. Definitive proof of hoisting plus the dead zone.
Wow, okay. So let's recap the lifecycle differences quickly. var.
Hoisted and auto-initialized to undefined immediately at the start of its function scope.
Let and const.
Hoisted, name registered at the top of their block scope. But initialization is deferred until their declaration line is executed. That gap is the TDZ.
And the TDZ causes that specific reference error if accessed too early.
Correct.
So practical advice, how do you just avoid TDZ errors altogether?
It's pretty straightforward, actually. Just make it a habit. Always place your let and const declarations at the very top of their scope block.
Physically write them first.
Yep. If the declaration is the very first thing in the scope, the temporal dead zone effectively shrinks to 0 length. There's no time between the scope starting and the initialization happening. Problem solved.
That's great practical advice. Put your lets and consts at the top. Okay, this has been a really important deep dive. Much more to the variable lifecycle than just scope shapes.
Definitely.
We covered that compile time registration, hoisting the big initialization differences between var, let, and const, the rules about redeclaration, and this crucial idea of the temporal dead zone.
Absolutely. And hopefully shifting that mental model slightly, thinking about the compiler's role and the two-phase process, makes these twists and turns feel less confusing, you know?
Yeah, it clarifies things.
Understanding this life cycle properly, especially the way let and const work with block scope and the TDZ, it really sets you up to make better decisions about how you structure your scopes, which is exactly where we're heading next.
Excellent. Well, thank you for joining us for this really essential look at JavaScript's variable mechanics. We hope it was helpful for you.
Catch you on the next one.